Hello students, today we are going to discuss fifth program of your part A, right? Okay, that is to find square of a given number, the numbers ranging from 1 to 10. Okay, so we have seen how to create a project, right? Okay, so first what we have to do, first we have to close the existing project, right? Okay, then we have to create new vision project. Create one folder on your desktop or any drive, whichever suitable for you, right? Okay, so first create the new vision project, right? Okay, we'll get here you have to select NXP founded by Philips, right? Okay, so under this you have to select LPC 2148, right? Because you are studying microcontroller LPC 2148, so we are working on this microcontroller, right? Okay, so for part A programs, no need to add startup file. Okay, so just we need just give no, right? For part B programs, we are going to add, right? Okay, you will get one source group under the target, right? Okay, so next create one new file. Okay, here you have to type the code. Okay, so this is your program, right? Okay, so this is your question. Write a program to find the square of a number. Okay, so here they specified number from 1 to 10 using lookup table. Okay, so you have to have lookup table which will be in memory. Okay, we'll be fetching the address of lookup table from the memory, right? Okay, so we will be square and save it early. Just we will fetch from the lookup table. Okay, so in this is your program. Okay, just I will copy paste. I will explain step by step in detail, right? So first create one text file, right? Okay, here you have to type your code, right? Okay, after typing the code you have to save it. Okay, go to save, right? Okay, so just you have to save, right? Okay, so where actually your project existing, right? Okay, you have to create one folder, right? Okay, so where your project is existing, right there you have to create your file. Okay, so your file should be saved, right? Okay, so for example, since we are calculating square, so I will give square. You have to give file name with extension .asm, right? Because this is assembly code. Okay, save it in .asm extension. Okay, just save, right? Okay, so yeah, you have typed the code and you have saved with the extension .asm, right? Okay, so next you have to add this file to your source group, right? How to add? Just right click on source group, right? Okay, so here you have add files to group, right? Okay, so just you select here file type. Okay, C source type is there, so our program is assembly code, right? Okay, assembly code asm source file. Okay, assembly code we know that will be saved with the extension .asm, right? Okay, so either you give .s or .src or .a or .asm. Okay, you can give any extension among these four, right? Okay, so select asm files. Okay, so our program is what? This one, right? Square.asm, right? Okay, just add, then close. Okay, so you can see here dash key, right? Okay, so next step is what we have to build. Okay, so to check whether this is correct or not, we have to build. Okay, so here is build, right? Build target files. Either you can press F7 from your keyboard or just use this icon build, right? Okay, so it will display if any errors are present, otherwise it will display 0 errors 01. Okay, if you get any errors, it will show the corresponding line number, right? Go to that line number, right, and just you edit it and clear the errors. Okay, if no errors, 0 error 0 warning, you can directly go for checking of the output. Okay, so before going to output, we'll see what actually this program will do, right? Okay, so see here. Okay, so we know that area, which specifies area section square. Okay, this is your name of the program. This is user defined. You can give any name which is related to the program, right? Okay, so code we are specifying it as read only, right? Okay, so next we have entry section. Okay, start. Okay, so here we have lookup table, right? Okay, so since in question they are specified, you have to find square of the numbers range they have given from 1 to 10. Okay, so in lookup table first we'll find out square of the numbers from 1 to 10. Okay, so we'll save it as the array. Okay, so actually this will be stored in your memory location. We'll see how it will be stored and how it will be fetched, right? Okay, so here we are given name table1. You can give any name, right? Okay, so you can give any suitable name, and same thing should be used while loading its starting address. Okay, so no need to give table1 itself. Okay, you can give any name related to particular task. Okay, but while referring, you reference the same name, right? Otherwise it will display the errors. Okay, since numbers from 1 to 10. Okay, anyway here we start with 0. Okay, so for 0, 0 square is 0. For 1, 1 square 1. For 2, 2 square is 4. 3 square 9. 4 square is 16, right? Okay, 16 hexadecimal value is what? 10. Okay, so we are saving it 10. Okay, as I told, right? Okay, so every data right in your register, it will be stored in types of hexadecimal value, right? Okay, so every data in your register will be in hexadecimal value, right? Okay, 16 hexadecimal is what? 10. Okay, so 25 hexadecimal 19. 6 square is 36. It's hexadecimal 24. 7 square 49. 31 hexadecimal. Okay, for 64 40. Okay, so and so up to 10. Okay, 10 square is 100. Its hexadecimal is what? 64. Okay, so this is your lookup table. Okay, this one you have to refer, right? Okay, and you have to display square of a particular number. Okay, look here. Here you are using the registers R0, R1 and R3. Okay, mainly you are using these three registers, R0, R1 and R3. Okay, so R0 contains what? Starting address of this table, right? Okay, R0 contains start address of your lookup table, and R1 contains to which number you are going to calculate the square. Okay, so here we are taken from 1 to 10, right? Okay, for example, if you want to find square of 2, okay, so place 2 here. Okay, so that 2 will be moved to R1. If you want to find out square of 5, okay, in place of 5 you just rewrite or edit as 5. Okay, 5 will be saved in R1. Okay, so next we'll do left shift performation. Okay, logical left shift. Okay, I will tell how it is done. Okay, so after adding, finally resultant will be stored in R3. Okay, so after execution, what you have to do? Okay, so you have to check the result in R3. Okay, because the final content resultant R0 is loaded to R3. Okay, so in our program, right, the final resultant is stored in register R3, right? Okay, so we'll now see the tracing, right? So here, what is first step? Okay, so first we'll run the program. So parallelly, you can see the tracing, right? Okay, debug, go to debug. Here you have start or stop debug session, right? Okay, here just you give okay. Okay, you will get this screen. Okay, this is your output screen, right? Okay, so this is your register window. Okay, in all the part A programs, you have to see the output in registers, right? Okay, this is your program. Okay, we'll see how it is executed. Okay, so we'll execute step by step, right? Okay, see here. So what is PC now? 0. Okay, what does PC contains? We know that PC contains start address of means address of the next instruction to be executed, right? Okay, and we know that every instruction is of 4 bytes, right? Means we know that this architecture is of 32-bit processor. Okay, here each instruction will take 4 bytes. Okay, so every time we go to next line, the PC will increment by 4. Okay, which is nothing but your length of the instruction, right? Okay, so we'll see. Okay, this is for run purpose. Okay, either you can do complete run operation. Okay, complete run means it will display the final content of the register, or you can go step by step. Okay, step by step means what? Okay, after each line, okay, what is the present content of the register that can be seen. Okay, so still we are in early stage. Okay, we'll perform step by step word execution and see what is the contents of the registers, right? Okay, so what is the first line? Okay, anyway we define its name as square and this code is read only, right? Okay, so entry, this is your entry section. Start is just a label. Okay, as we have seen, the first column is reserved for labels, right? Okay, this is reserved for labels. Okay, first instruction is what? We are loading your lookup table address. Okay, here we have named it as what? Table 1. Okay, table 1 address that will be loaded to R0. Okay, so what is the early contents? R0 is 0. Okay, so if you run this instruction, right? Okay, so previously PC is what? Program counter value is what? 1 0. So if you go to next line, it will increment by 4. Okay, so for 0 line, this is the content, right? Okay, so counter contains what? Address of the next instruction. Okay, so address of the next instruction is this one. Okay, so next we are going to load R1 to 2, right? Okay, so next 2 will be moved to R1. Okay, so if you see here, okay, we have this yellow color line. Okay, so here the program counter is pointing, right? Okay, but now present executed instruction is what? We have loaded the address of the table to R0. Okay, right? Okay, so R0 table 1 is loaded to R0. R0 address is what? Something like 18, right? Okay, so we can see what it contains in memory location. Okay, here you can see memory, right? Okay, so in this address bar, okay, just you give this value. Okay, so this value is what? The start address of your lookup table, right? Table 1, right? Okay, the address is this one. Okay, you can cross verify. Okay, just you give this address 0x, right? I think this is the value, right? Okay, so here you can see, right? See here, so this is your lookup table, right? You can it is similar to your array. Okay, so it will take what? Continuous memory location, right? Okay, so here also it is taking continuous memory location, right? Okay, first value is what? 0, right? Next value is 1. Okay, 4 9 10 19 24 31, right? Okay, 40 51 61. Okay, so it is similar to array, right? Okay, it will be stored in memory continuously, right? Okay, so you can see the tracing part also. Here first step is what? Table and 1 address is moved to R1. Okay, so in our execution this is the address. Okay, it will be moved to R0. Okay, so next we have taken 2 here. Okay, so try for all combination. Okay, ranging from 1 to 2. For first tracing I have taken the number 2. Okay, so we have taken number 2. Okay, we know that the square of 2 is what? 4. Okay, finally we have to get 4 as the answer, right? Okay, we have to choose one number between 1 to 10, right? Okay, so that will be moved to R1, right? Okay, that will be moved to R1. Okay, we are going to find out particular square that will be stored in register R1, right? Okay, now for this case we have taken 2, number 2. For 2 we are going to calculate the square. Okay, now R1 contains 2. Okay, So this is how elements are stored in your lookup table, right? Okay, so we have taken 0 square 0 0 0. Okay, so see here 0 1 is will be upward. Okay, so you read it as what? LSB comes first. Okay, this is the MSB. Okay, this is like 0 0 0 0 0 1. Okay, so next 0 0 0 0 4. Okay, so now like this it will go, right? Okay, so if you see here, LSB comes first, followed by the MSB bit, right? Okay, so this is how it is stored, right? So this is your LSB bit, this is your MSB bit. Okay, so 1 2 3 4. Okay, so these 4 locations. Okay, totally it is 4 bytes. Okay, so 4 bytes means what? 32 bit. Okay, since it is a 32 bit processor, right? Okay, so each register is of 32 bit, right? Okay, we have seen instruction, right? Okay, so how many register, what is the size, okay, types of register, all those things we have seen. Okay, no need to explain again here. Okay, so we know that register is of 32 bit. Okay, so this will be the LSB followed by the MSB bit. Okay, this is first location. Okay, means square of 0, these 4 bytes. Okay, next 4 bytes is square of 1, next 4 bytes is square of 2, square of 3, like that. Okay, means each element, okay, if you see here, this one, each element takes 4 bytes. Okay, so 4 bytes 4 bytes 4 bytes 4 bytes. Okay, each element will be taking 4 bytes. And since I told, right, okay, so every element is of 4 byte, that is 32 bit. Okay, if you know the start address of the what lookup table, you can calculate remaining thing, right? Okay, if start address is 18 means 000 followed by 18. Okay, 18 plus 4 means 4 means this 4 bytes. Okay, why we are adding 4? Because its size is 4 bytes, means 32 bit. Okay, so just keep on adding plus 4, we'll be getting the address of the next location, since the location is continuous, right? Okay, 18 plus 4 is 1C, 1C plus 4 is 20, 20 plus 4 is 24, plus 4 28, plus 4 2C, plus 4 3C, it goes on like that, right? Okay, so these are the addresses of the corresponding elements. Okay, so now what we have to do, so to display corresponding square of a number, we have to get this address. Okay, so if you get the particular address, okay, just we can get the content, means the content or the value present in that address. Okay, which is nothing but the result, right? Okay, so what is next step? Okay, so simultaneously you can observe the value of PC, how it will be incremented. Right, okay, next step is what? Okay, so for which number you want to find out square, that you move to R1. Okay, so now I am taking the number 2. Okay, you take 5, 6, 7. Okay, you take any number, just you replace and move to R1. Okay, so here I am taking the number 2. Right, and I'm moving it to R1. Okay, so R1 is what here? 0. Okay, if I execute this statement, so what I will get? R1 content is 2. Okay, so here we can see the R1 content is 2 now, because I have moved R2 to R1. Okay, and see, PC is incremented by 4. Right, okay, so previously it was 4, now it is showing 8. Okay, so 8 is the 8. Okay, 8 address line, this is the instruction, right? Okay, so what it does, move R1 comma R1. Okay, means LSL what? 0x2. Okay, LSL stands for what? Logical shift to left. Okay, so LSR means logical shift to right side, LSL means logical shift left side. Okay, so followed by, you have to specify the bits, means how many bits you have to shift, right? Okay, see here. Okay, here we have to shift by 2 bits here. Why? Okay, as I told, okay, we know that if you perform left shift, it is similar to multiplication. If you perform right shift, it is similar to what? Almost division. Okay, so if you shift 1 bit 5 left, okay, it is nothing but multiply by 2. Okay, if you shift a number to left side by 1 bit, it is similar to you are multiplying a number by 2. Okay, so here we are shifting by 2 bits. Okay, 2 bits means what? Into 2, it is almost similar to you are multiplying it by 4. Okay, why we want to multiply by it 4? Because each element, right, okay, is of 4 byte. Okay, to get address of corresponding next location, right, that corresponding number has to be multiplied by 4. Okay, so that you will get correct address, right, of that element, right, and you can fetch the result from that memory location, right. Okay, so in first tracing, right, we have taken the 2. Okay, so now the content of the register R1 is what? 2, right. Okay, 0x, okay, it is a 32 bit, just I have taken it as 02. It is nothing but like this. Okay, in your register 0x, 6 zeros followed by 02. Okay, so in 32 bit we represent like this, right. Okay, this is 32 format of means actual register content of R1, that is 2, right. Okay, its binary value is what? 0010. For 2 we write 0010. Okay, so remaining all MSB bit you fill with zeros. Okay, this is R1, right. Okay, the content of the R1, right. Okay, so will be shifted by 2 bits to left side. LSL stands for what? Logical shift left. Okay, we have to now shift left side. How many bits? 2 bits. Okay, why? If you shift by 1 bit, it is similar to multiply by 2. If you shift by 2 bits, it is like we are multiplying it by 4. Okay, so if 1 bit it will come here, second bit it will come here. So after shifting the content of the registers by 2 bits, this is the resultant, that is 1000. Okay, so its equivalent number is what? 8. Okay, so after shifting the content of the register R1 left side by 2 bits, okay, so that is now we'll get resultant as 8. Okay, and you have to save it in the same register, that is R1, right. Okay, so the new value of R1 is what? 8, right. Okay, so now the new value of R1 is 8. Okay, if you see it is same. Okay, if you the number is 2, if you multiply by 4 you will get 8, right. So 8. Okay, next step is what? Okay, see here. Okay, next step is what? We are adding the content of R0 with content of R1, right, and you are storing it in R0 again. Okay, so it will rewrite. Okay, once we add content of R0 and content of R1, the resultant is stored in R0. Okay, so what is R0 and R1 now? We have seen, right. Okay, R0 contains what? Lookup table start address, that is this one, 000018, right. Okay, and R1 is what? Okay, this is 8. Okay, 18 plus 8 you will get 20, right. Okay, so 20, what is the value present in 20? Value present in 20 is 4. Okay, means 00004. Okay, because this is your LSB bit, these are MSB bit. First comes LSB, right, while saying 4. Okay, so we'll get 4. Okay, so which is nothing but what? The square of the number 2. Okay, so if you see here, we have taken 2, right. Okay, and we are getting output as 4. Okay, so 4 is nothing but what? The square of the number 2, right. Okay, you can see in output, right. Okay, so next step, add R0 and R1. R0 contains what? 00018. Okay, so now content of R1 is what? 8. 18 plus 8. Okay, add R0 R1, right. Okay, and again save the result in R0. Okay, so the new value is what? R0 plus R1 This, after adding, you will get 000020. Okay, so that is your R0, right? Okay, now this is nothing but your memory location, right? Now you have to fetch what? The content present in this memory location, right? That is moved to R3, right? Okay, so how to know what is present in this memory location? Just we can cross verify. Okay, so just give this memory location, right? That is 0000, right, 20. Okay, so just if you enter, okay, you can see it. Okay, so you have 4, right? Okay, so 000004. Okay, so this is your LSB bit, this is your MSB bit. Okay, at 20 memory location, right, the value present is what? 4. Okay, so you know that this square bracket indicates what? The square bracket indicates you are going to fetch the value. You are going to fetch the value present in particular address. Okay, so present in particular address. Address is what? Address present in R0 here. Okay, 20 is the address, 4 is the value. Okay, so what is the resultant now? 4. Okay, so 4 is nothing but the square of 2. Okay, so in exam what you have to do? To which number means input should be given in register R1 and output is read from register R3. This one you have to remember, right? Okay, so input is given to R1, output we are fetching from R3. Okay, so we can see here, okay, that will be moved to R3, right? Now we execute that line. Okay, so you can see R3 now, you got 4, right? Okay, so 2 is the input, the square of 2 is what? 4. Okay, so final output is present in register R3. Okay, so you have to show out, you can see here, okay, that it is in red color. Okay, so after execution of particular line, it will show in red line, means here this is your output and also you have to show in register. Okay, so output you have to show in register as well as memory location. Okay, so in 20 location 4 is the resultant. Okay, so that will be moved to R3, show the resultant in R3 also. Okay, so next stop is stop. Okay, anyway it is an infinite loop. Okay, so this is your end of your program, right? Okay, so anyway this is your lookup table. So we can trace it for another number. Okay, before editing your code, first you have to stop debug. Okay, okay. So for example, now we'll check for the number 4. Right, okay. So for which number you want to find out a square, okay, so that you load to register R1, okay, and result will be stored in R2. If you make any changes to your code, first thing is what? You have to save, right? Okay, every time you have to save. If you make any changes, you have to save your code. Okay, so before running, you have to again build it, right? Okay, so before actually seeing the output, first you build, okay, to check after editing your code any errors is there or not. Okay, so if any errors is there and you are running, what it will do, it will run the previous exa file. Okay, it will not take your edited file. Okay, so that's why every time you edit your code, if you change any changes in your code, if you make any changes in your code, every time you have to build, right? Okay, so if you get 0 error, 0 warning, then you can go for build. Okay, now the taken number is what? 4, right? Okay, so for 4, what is the 4 square? 4 square is 16. 16 xi is what? 10. Okay, so this should be your resultant. Okay, so we'll see now. So start debug. Okay, here you give okay. Right, okay. So every time you check the content of PC, means how your program counter is incrementing, and you can go through line by line. Okay. So first line is what? You are moving the your lookup table address to R0. Okay, first step is anyway 18. You can see the contents are same because we have taken the same program, right? Okay. So 0149. Okay, so the contents are same. Okay, so since it is a continuous memory allocation, right? Now we are taken 4, right? Okay, So just you move it to R1. Now R1 contains 4. Okay, now you have to perform left shift the content of R1. Again you are saving it in R1. Okay, so after performing left shift operation, the resultant is stored in R1. Okay, so here you can see. So here, taken another example with 4, right? Okay, so if you perform left shift by 2 bit, okay, so here you have 4, right? 4 is nothing but 0 1 0 0, right? If you perform left shift by 2 bit, okay, 1 bit 2 bit, okay, 1 comes here, okay, here you can see here 1 comes here, so resultant is what? 1 0. Okay, so it can be written as 6 zeros followed by 1 0, or you can just write 1 0. Okay, it is understood that all the left sides are 0. So next step is what? You have to add content of R1 to content of R0 and R1 and save it again back in R0. Okay, so R0 is what? Start address of the lookup table, that is 00018, right? R1 is now the resultant whatever you got after shifting left right by 2 bits. Okay, 4, the number 4 is shifted left side by 2 bits, you will get 1 0. Okay, you add these two. Okay, 1 8 plus 1 0, you will get 2 8. Okay, so this is your address. Okay, so you see the content, or what is the content present in this address, that is your resultant, right? Okay, so we can see here, so after this line 4 left shift by 2 bits, okay, we'll get 1 0 as I told, right? Next you have to add R0 R1, again store it in R0. Okay, R0 contains what? 1 8, R1 contains 1 0. Add these two, right? And store again result back in R0. Okay, you have to observe now, so how the register contents are changing. Okay, so now the new value of R0 is what? 2 bit. Okay, so now you have to fetch the content of R0, right? And you have to move to R3. So what is R0? 28, right? So 28. Okay, so if you see here, you will get 1 0, 1 0 0 0 0 0. Okay, you have to read from here, 0 0 0 0 0 1 0. Okay, so 1 0 is nothing but a hexa value of 16, right? Okay, 16 is what? The square of number 4, whatever you have given, right? Okay, so execute next line. So you can see here 1 0 present in R3. Okay. So here you see the color has changed after executing particular line. Okay. So this is how we have to show the output. Okay. The program is simple. To which number you have to show right square, you have to move it in R1. The output is present in R3. Okay. For any given number, you have to perform left shift by 2 bits. Why? It is similar to multiply by 4. Why 4? Because each element will take 4 bytes, because it is 32 bit, right? Okay, it will take 4 bytes. Okay, so that's why you have to multiply by 4, right? Okay, so it is similar to what? Left shift by 2 bits, it is same as multiply by 4. Okay, so the output you have to show in register as well as memory, right? Okay, so this is your fifth program. Okay, if you want, you can change to one more number. Okay, we'll see. So if you want, you can give 10. So if you make any changes, just save it, right? So then build, right? Then debug, right? Okay. So you have already executed, right? Just it is like revision. Okay, anyway, it is done in class. You executed in lab also, right? Okay, just you run. You every time you observe the content of PC and what are the register you have used, all those things. 18, which is start address of your lookup table. So R1 is moved to A, right? YA 10, right? As I told, the register contains, right? Okay, so it contains what? Hexa values, right? Okay, exa value of 10 is what? Yeah, that's why it is storing. Yeah, right, okay. So next, after left shift is 2 8. Now add 2 8 and 1 8. Right, that is 40. Okay, so content of 40 will be moved to R3. So R3 is what? 64. Okay, you can see here, right? 10 square is 100, right? Okay, 100 exa value is what? 64. Okay, so 10 square we have to get 64. The input we are given is 10, output we are getting as 64. Okay, yes, 64 is what? The exa value of 100, right? And 100 is square of the number 10. Okay, you can also check in memory location. Okay, so we have to give r naught, right? What is r naught? 40, right? We give 40, right? Okay, it will show 64. Okay, so 64, which is exa value of 100. 100 is nothing but the square of the number 10. Okay, so this is your program 5, right? Okay, so just in your observation and record, right? Okay, so you write this output register content as well as this memory content. Okay, both should be present, right? Okay, and also this tracing. Okay, you try for different numbers. Anyway, we have done in class, right? Okay, this is like just revision, just to glance. Okay, so just you note down all these things in your observation, right, and update everything, right? Okay, so I will stop here. Okay, thank you.